Okay. There we go. Well, welcome everybody. As Dave said, I think we all know there's a lunar eclipse in the morning. So this is just a introduction to that with a slightly different twist. I'm going to go to the annotation so that you can see my cursor here. You see that moving around there. So no, I've got to move it out of the way. There it goes. All right, so I've always been fascinated with Earth's shadow ever since I first saw it and knew what it was. So we know that the Earth has a shadow, but most people have seen it, but not recognized it for what it was, like me, years and years ago. And the Earth's shadow is why we have a lunar eclipse. Now, this setup right here, I took a picture of this little model balloon Earth and in the morning, and had it from outside the house, and then had it projected on a wall inside the house so that you can see Earth's shadow. Now, so here's the outline for my talk here. The first is, when can we see Earth's shadow? Then what Earth's shadow and the correlation between Earth's shadow and lunar eclipses. And when and from where to watch tomorrow's eclipse. Probably, I hope a lot of you already have your spot chosen, but for those of you who don't, I'll give you a couple of tips, and then what you might need. And of course, coffee, right? Because it's too early in the morning. All right, so let's see. When can we see Earth's shadow? Now, every evening and every morning, you actually can see Earth's shadow up against the atmosphere. But just like we in the previous slide, you have to have something that the Earth's shadow is being projected against in order to see it. Like in this case, our atmosphere. This is our atmosphere, and this blue band, if you look to the west, opposite where the sun is setting in the evening, just after it's set, you'll see this blue band across the sky with this pinkish band above it. And that blue band is where the Earth is starting to turn into its own shadow. That's Earth's shadow there. And it gets higher as the Earth turns farther into its shadow. And of course, standing in the shadow of the Earth is nighttime. All right, let's see, what else do I want to mention here? Yeah, that's it. But on the top of Mount Diablo, we have a very special thing that happens every so often. And a lot of people get pictures of this. And you can see that the sun is still shining at the top of Mount Diablo. And this is just before sunset, right, almost right on the horizon, when the sun is right on the horizon. And to the east, you can see the outline of Mount Diablo projected against our atmosphere. So that's the beginning of Earth's shadow that we can see up there. And then of course it gets thicker and thicker and then just turns into that bluish band that we saw on the other side. And of course, the other time that you can see them is during a lunar, see the Earth's shadow is during a lunar eclipse. So let's take a look at a diagram of Earth's shadow. This is way not to scale, but it just gives you an idea of what it looks like. The darkest part of the shadow is right here. If you want to know what the penumbra is and why we have a penumbra and all that stuff, you can look that up on Wikipedia or something. But this is the darkest part of the shadow. We stand right in here at night. And we also know that the moon orbits the Earth, and every so often, it passes through the darkest part of our shadow. And if it passes, if it goes completely into Earth's shadow, that is a total lunar eclipse. Let's see. Yeah, it's the only time that the whole moon is in darkness. And our sky will be dark during a full moon at the same time. And many of you probably know that tonight's full moon is also supermoon, when the moon is closest to us in its orbit around us. I'm not going to talk about supermoon today. I'm focusing on our lovely shadow here. So, but how big is Earth's shadow at the distance of the moon? Now, Earth is roughly 8,000 miles in diameter, and here it is again projected against a wall, and it's at the distance of the moon. Our Earth here is about 4 inches across, so it's about 10 feet to where the moon would be at, you know, if the moon would be about 10 feet away from us on that scale. And so the moon has to hit this little target right here in order to have a total lunar eclipse. But how big is the Earth's shadow, as we said? Well, here's the little diagram of the moon, the Earth's shadow at the distance of the moon. These two are to scale. Now, the moon in the sky is about 1/2 degree of sky. And your hand can be used to determine several different sizes. I'm going to show you 3 different ways to use your hand to measure things in the sky. And the first one is the moon at 1/2 degree. If you hold your pinky out at arm's length, close one eye, and hold it up against the sky, and hold it over the moon, you'll see that the moon is completely covered by your little pinky. So your little pinky is a little bit bigger than 1/2 degree. So you put it up against the sky, put it up against the moon. Now, Earth's shadow at the distance of the moon is about 1.3 degrees. And so which finger can we use for that? Your thumb. So your thumb held at arm's length from one side to the other, that's about roughly 1.3 degrees. And so if you hold your thumb up to the sky, it's all in this corner here. If you hold your thumb up to the sky, that can cover Earth's shadow in the sky. So it's pretty small. So there's the thumb. And then it takes the moon about an hour to move its own width through the sky, you know, as it's orbiting us. And so so what's totality? This is not totality. That's still in its partial phase when the moon is partly into Earth's shadow. Total phase is when it's completely within the Earth's shadow. And then at this point, you know, it still takes, it always takes about an hour to move its own width. So how about the length of totality? We know that the length of totality tomorrow is really short, and I'll show you the schedule in a minute. But the maximum is a little less than 1 3/4 hours. And that's when the moon takes a path right through the middle of the Earth's shadow. Now, but tomorrow's is less than 15 minutes. So that means that the moon must be skimming almost skimming along one edge here and going, you know, approximately like that, because it's within our shadow for only about 15 minutes. I think it's actually 14. So let's look at the schedule. All right, here we go. So 2:44, if everybody wants to get up that early, just watch the beginning, that's great. That's when the partial eclipse begins. This is from here, from where I am in moment 2. But here's where total eclipse begins. But where is the moon? The moon is at 225 degrees from north, 225 degrees from north, and that is southwest. Also, it's only 16 degrees above the horizon. It's very low in the sky. So what I usually tell people when they ask is I say, hold your hand out at arm's length. I always put it out at arm's length. That's for these measures.
Marnie, we're having trouble hearing you. I think you're backing away from the microphone.
Okay, sorry,
Okay,
thank you. Is that better? Is that any better? Yes, no?
Yes.
Yeah.
Okay. I'll pull it up a little bit farther. Okay, hold your hand out at arm's length like this, and then turn it to the side and line up the tip of your thumb with the height of your eye, and that marks your personal horizon. Now, from here to here is roughly 15 degrees. So at your personal horizon, which is, you know, like a flat, if you had a flat horizon, you put this side, this would mark a flat horizon. But if you've got trees and hills behind your hand at this point, you're not going to see it because it's too low in the sky to see. If you have clear sky somewhere around your hand, then you know that you can see the eclipse. I hope that was clear. It's so much easier to do in person, but with everybody holding their hand up. You can try it right now if you want, if you have any questions. Okay. So that was the 3 measures. Your little finger, the size of the moon, your thumb, the size of our shadow, and that is 15 degrees, all at arm's length. And it's easier to see if you close one eye. Okay, so where do we go to watch it? Well, I hope that a whole lot of you saw the conjunction back on December 21st of Jupiter and Saturn. Wherever you went to see the conjunction shortly after sunset, you can go to exactly the same place, but at 4 a.m. Let's see what that looks like. So here's the conjunction on December 21st, 5:30 p.m., right after sunset, Jupiter and Saturn. This is in the southwest, roughly 15 degrees above the horizon. Here's Capricornus. But tomorrow morning, the moon is almost precisely in the same place over the southwest, but you're in Scorpius instead. So you see, you can see that the moon is going to be at almost precisely the same height just before totality at 4:05, and as where the conjunction was above the horizon. So 4 a.m. and I want you to notice these 2 stars and Antares here, because we're going to zoom in on this area right here. and watch, put the whole thing together and watch it. You'll also notice there's a little star right next to the moon right there. And we're going to have that marked as a reference. So let's go to the video. And here's the video. Here's Antares right here. These are those two stars of Scorpius. And this star is the reference star so that you can follow the path of the moon through the sky. And you can see, based on that star, that the moon is moving across the sky in its orbit. That's one of the nice things about eclipses, is that you actually can see the movement of the Earth, of the moon. And the video is also going to draw a circle where the Earth's shadow is. So let's get this started. And there's the location of Earth's shadow. 2:44 is when the partial phase begins. By the way, this is really speeded up. It's going to take a couple of hours and do it in 1 minute. So you can watch how the moon is moving almost even with that reference star. And now it's 4:11, where the totality begins. And moments later, 4:25, totality ends. 14 minutes later. And it continues to move out, and you can see how the moon is moved in relation to that star. And here comes the horizon coming up to meet the moon and covering up the moon. So, ta-da. So go out there, figure out where your spot is, bring your coffee, bring your coffee mug, coffee jug, your binoculars, and go out and watch so that you can see the Earth's shadow on the moon. And that is a lunar eclipse. Hope you have a fun time.
Thank you, Maureen. That was really good. All right.
It's
Yeah.
interesting that, as your video shows, the moon is moving towards the east from our point of view. But because the Earth is rotating to the east, it actually looks to us like the moon is moving to the west.
Right. Yeah, because there's that movement of the Earth that makes the moon look like it's going that way, but the moon is actually moving counterclockwise.
Going the same
across
direction.
the sky.
It's going the same direction that the Earth is rotating.
Right.
Yeah.
Mhm. Yep.
All right.
Yes, I see a hand. Rob.
Yes, I'd like to make two comments about this eclipse, which you didn't touch on, which are very interesting, I think.
Very good.
Sort of going further, if you will. And it's actually inspired by the 2015 eclipse, April of 2015 eclipse, which I don't know if you watched that one or not. It was a even shorter totality, this one, forecast to be 4 minutes long.
Wow.
It was also at about 4 in the morning. It's like a little before 4 in the morning was that 4 minutes, and I was up for watching it. And myself, as well as many online observers, were not convinced that it was actually a total eclipse. We always saw a little sliver of light. And upon further reading, the size of Earth's shadow is not as well known as we think it is. So sometimes this eclipse remember those start times, end times are forecast, and due to atmospheric conditions and things like that, they may be slightly longer than that or slightly shorter than that. And that one in 2015 is the first time I ever was aware of that the uncertainties in the size of Earth's shadow was greater than I thought they were. Great enough that you could miss a total eclipse. And the other thing I'd mention with this eclipse, very interesting, and this was 2018, I saw this phenomena because the eclipse takes place right before sunrise. The totality is shortly before sunrise, and the partially eclipsed sky is still in the western sky. If you're lucky enough to be in a place where you have a clear western horizon and a clear eastern horizon, because atmospheric refraction makes the moon a little bit higher and the sun a little bit higher, you can actually see the sun rise in the sky and an eclipsed, or in my case in 2018, partially eclipsed moon still in the west. So I saw the sun and a partially eclipsed moon at the exact same time in the sky, which this was another opportunity to do that. Of course, I was on Kip Peak, so I had nice clear horizons. So, but if you have really clear flat horizons, you have a chance at seeing that. It's called a selenolite. I had this pronunciation.
Okay.
Yeah, you can look it up. It's a word. Trust me, there's a word for this. Selenolilium, something like that.
Okay. Thank you, Rob.
Yep.
Okay. Any other questions on here? Let's see. I'm checking. Okay. I don't see any other questions.
No.
Oh, how about restarting in-person meetings? Yeah, I'll let Dave address that. Thank you for all your lovely comments. I appreciate that.
One other comment to make on the eclipses, may be a little redder than your typical one. And the only reason I say that is because we've had some recent volcanic eruptions, which might be adding an extra layer of or level of dust and gases into the atmosphere, which might, because they've seen this before when what was it, Mount Pinatubo, I think, went off. The subsequent eclipses are very red, so we might have even darker one than normal. So anyway,
Also because it's low in the horizon. It's low in the horizon, so we're looking through more atmosphere to see it.
well, that certainly is a factor, but if you think about the fact that all the sunrises and sunsets cause the moon to be red, it isn't just your horizon that's doing it, it's everybody's. So, but yes, you're right in saying that you're looking through more atmosphere. So that's certainly true. Okay, now, I think we now proceed to our main presentation. And continue to go ahead and use the chat function in Zoom to ask any questions you might want to. And our presenter this evening is Mr. Robert Sparks. He will be presenting random adventures in astrophotography, chasing unusual events with the DSLR. Just right up our alley.
Okay.
Mr. Sparks earned his BA in physics from Grinnell College and his MS in physics from Michigan State University. He has built his career in astronomy education at a variety of institutions, including Good Hope School, St. Stephen's Episcopal School, the Prairie School, and Rob has received the 2001-2002 Fermilab Teacher Fellowship, where he worked on the Sloan Digital Sky Survey, and the 2003 NARO research experience for teachers, where he worked on mapping sources of radio frequency interference on the Green Bank Telescope. He has also served as Chandra Teacher Resource Agent and a NASA Astrophysics Educator Ambassador for the SWIFT mission. He is currently in the Communications, Education, and Engagement Group at Noir Lab in Tucson, where you happen to be right now, in fact. When not working, is frequently seen on stages or Zoom shows in Tucson as a member of various improv and music performing groups. He notes a fun fact: he has an Erdos Bacon Sabbath number of 10. I'll let you guys look that up. I'm pleased to introduce Mr. Robert Sparks. Uh-oh, I think you're muted, Rob. You're muted, Rob.
Thank you. There we go. Now I should not be. I say, I hope my slideshow is actually working now. Is it?
Yes, it is.
Yes.
Okay, super. So thanks for that introduction. It's I do a lot of fun stuff there. So Unscrewed Theater, if you ever want to check it out, one of our Saturday night shows. We have family-friendly shows every Saturday night at 7:30. So, and you said I've also worked as a NASA Astrophysics Educator Ambassador, and that's where I met Jeff Adkins, one of your members who is one who all took me up with this, and I've worked with him on various projects throughout the years. So I've always known Jeff for a long time friend. So anyway, let's see. Oh, there we go. And I'll tell you what NSFs Noir Lab is first. It's a fairly new organization. I expect many of you haven't heard of it yet. You might have heard of the National Optical Astronomy Observatory. That's what we used to be known as. But in 2019, the National Science Foundation decided to bring all their NSF-funded ground-based nighttime astronomy under one umbrella, and that's when Noir Lab was born. They did that by merging what was National Optical Astronomy Observatory, along with the Gemini Observatory and Cerro Tololo Inter-American Observatory down in Chile, and the Rubin Observatory, which was formerly known as the Large Synoptic Survey Telescope, will merge with us when they start operations as well. They're still in the construction phase, and for various weird government budgetary reasons, they cannot merge with us until they start operations. But they will be coming on board here, hopefully in the very near future. If you don't know about LSST/the Rubin Observatory, it's a fascinating telescope in its own right. You can see our Noir Lab logo there, which was introduced in April of 2020 at the bottom right there. And this was put out as an announcement, and within an hour, literally, someone on Twitter gave us our unofficial logo. So they noired it up for us, if you will. So I like this version better personally, but that's just me. So, but just to tell you a little thing about my day job here and what communications, education, engagement do. I do things in all those parts. Social media team, the internal and external news team. I also actually have, as part of my job description, photography, doing mostly kit photography up on Kitt Peak, and that's where I am right now. I'm at Kitt Peak National Observatory, hoping that the clouds will stay away so I can get some pictures of the eclipsed moon over some of our facilities on Kitt Peak. I also host our Live from Noir Lab at Arizona, an online show a couple times, once every 3 weeks, because we rotate from Arizona, Hawaii, and Chile. We rotate through those 3 sites. We have 1 show a week. Education, I'm a Project Astro site leader, which is a program that pairs teachers and astronomers to work on science education. Color Studio Lab, a STEAM program. I teach observing skills to our undergrad employees when we have them. They do star parties. Haven't had to do that in the last year, but hopefully that'll be starting up again this fall. And of course, I will go out and do star parties as well. I do some curriculum development as well as review curriculum for other organizations, especially within next generation science standards is a very thing I've done a lot of work with. I do teacher professional development workshops and visit classrooms in person, and of course, this last year or so on Zoom. And I've even done some work with streaming live views of the stars at night and the sun during the day via Zoom as well. So I can actually show you solar flares and prominences with an H-alpha telescope live from Tucson during the day. As long as it's not too hot. Believe it or not, if it gets too hot during the summer, my computer literally overheats and shuts down. So during the winter months, I can do that. But during the summer months, I have to literally not do that because otherwise my computer will shut down. It happened to me the first time I tried it last year. Fortunately, it was not live to a classroom. It was just a test for some coworkers to see if we could do it. But I also do some engagement, staffing booths at professional meetings like the American Astronomical Society meeting and that sort of thing. Virtual Star Party Solar Observer, as mentioned. I also do our monthly podcast for us as well. So a lot of stuff that I do for my day job, and that's, believe it or not, only a partial list. There's still other things I've done in my day job over the years as well. So it's a lot of things involved here, which keeps me on my toes and definitely is a lot of fun. But you're here to hear about some astrophotography. So I've never had a grand master plan about the skills I want to develop, which has advantages and disadvantages as everything does. If I see something that's sort of I like to say, hey, that looks like neat. I just go out and do it, and I will mess it up the first time, maybe the first 2 or 3 times, and eventually get it right. So I don't worry about having some sort of master plan. I'm going to do this and this and this and plan out shots 10 years down the road. The one thing I do need to do, I need to learn more Photoshop. I'm sure some of you look at my pictures and say, oh, I could Photoshop that better. You're probably right. But I'd like to learn more Photoshop. That's something I do need to learn more. I know about that. I, of course, see other astrophotographers do things, and I get inspired to try things. I see them, ideas from them, and sometimes take them further. I like trying things people don't think will work. Trying to photograph things people aren't quite sure you could actually photograph with a DSLR and a zoom lens. And sometimes they don't work, but occasionally I will pull a surprise. I don't always worry about pretty pictures either. Sometimes I worry about just, can I get this thing that's very faint and difficult to photograph with minimal equipment and see what I can do and push things as far as you can. And that's sort of the things I like doing, So there's not much of a plan. So if this seems like it's a little bit broad-based, not scattershot presentation, there's probably a reason for that, because that's sort of how my astrophotography has been over the years. Sort of broad-based scattershot, trying different things and seeing what works and what I enjoy. And one thing, first of all, a little about my equipment. So, most of what I do, I have 2 main cameras I use. A Canon 80D, which was February of 2016 is when it came out. It's a crop sensor, 1.6 crop factor. And I'll talk about crop factors here. I want to talk about the full frame camera as well, to the difference between them. 24.2 megapixels, 3.7 micron pixels, so fairly small. Compatible with EF and EFS lenses. EFS lenses don't produce as big an image circle because you have a smaller sensor. You don't need as big an image circle. So EFS lenses tend to be a little bit cheaper than the EF lenses, which need to produce a bigger image circle. They don't have quite as demanding optical designs. They tend to be a little cheaper lenses. Of course, you can't use them on a full frame camera. I have a Canon 6D, which is a full frame camera, came out 9 years ago, 2012, almost 9 years ago. But it's a full 35 millimeter diagonal sensor, just like you'd expect. A 20.2 megapixel, so even though it's a bigger sensor, it has fewer pixels, which means the pixels are much larger, 6.54 micron pixels, so it has very good noise reduction, very good, very low noise. It's a very good astrophotography camera for that. But you need the EF lenses for it. So you need that bigger image circle because it has that bigger image circle. So you need a bigger lens that can boost that image circle well. So those are my two main cameras. Like I said, the crop sensor does have some advantages and disadvantages. Imagine you have a 100 millimeter lens, okay, on a 35 millimeter on the full frame camera. Well, that crop factor, because you have the smaller pixels, means that lens is going to magnify the image a little bit more for you. In this case, by a factor of 1.6. So 100 millimeter lens on the Canon 6D will produce we'll put that lens on the Canon 80D, it'll produce 160 millimeters, same lens as 160 millimeters on the 60. So put 100 millimeter lens on the 80D, that's equivalent to 160 millimeters on the 60. So you get a little extra crop factor there. So you basically get extra magnification, some bonus magnification by using a crop sensor, which has advantages and disadvantages, of course, because you also get a smaller field of view. So sometimes that's an advantage, sometimes it's a disadvantage, depending on what you're trying to do. Of course, I have an old Canon 7D my father gave me when he decided he didn't want anymore. I use it as a backup if I want to do 3 cameras at once. And occasionally I pull up my cell phone, which can do more than you think. Even an old OnePlus 6D, a 3-year-old cell phone, can actually get Milky Way shots and things like that, believe it or not. So it can do a little bit more than you might think of cell phone good. Lenses, I have a whole variety of lenses. These are things I picked up over the years for different purposes. The 1855, that's sort of a kit lens, comes with the camera. 24 to 105, that came with my 6D, that's a full frame one. The 7300 I picked up used from someone, which was a nice lens for a long time. 35 millimeter f2 gives a nice fast lens. F2 is a very fast focal ratio, so you get a very short exposure. I love that 10 millimeter diagonal fisheye because it's great for big, broad Milky Way shots. Gives you 167 degree field of view, so you can get almost half the sky at one time. So it's a wonderful lens for that. That Tokina 11 to 16 millimeter f2.8 is a nice fast lens, but it's not a fisheye. It gives you a non-distorted view. And that Rokinon 14 millimeter f2.8 is a very good introductory lens. It's a manual lens, manual focus, manual f-stops, so it's very cheap, but one a lot of astrophotographers like for their first really wide field lens. The Tamron 150 to 600, that's a nice one I use for a lot of close-up stuff, but it's also big and bulky and hard to travel with, so I picked up the Sigma 100 to 400, which is a better travel zoom, just because it's not as big and hard to travel with. And I also have the Sigma 14 millimeter f1.8 I got a few years ago when it came out. Be a very wide, extremely fast lens, and a Lens Baby 5.8 millimeter fisheye, which is a fun lens to play with occasionally. And I have a couple shots I'll show you in here from that one, which gives some unique perspective that only that type of lens could capture. So there are a couple shots you need a full true fisheye to capture some types of shots. That's sort of the collection of stuff I use mostly. I think that almost everything I took was using with one of those, in this presentation was done with one of those cameras and one of those lenses, except for one picture. I think there was one picture I took through a telescope, which I'll show you. I'll get to that later. So I also have a ZWO 1600 millimeter camera. It's a, I don't know what that prog means there. That's some gibberish. Maybe a cat walked on my keyboard while I was doing this. I can't remember. But it's a monochrome camera, 16 megapixel monochrome camera. And I also have a ZWO ASI 120C, which is a great planetary camera as well. So I got those fairly recently and put those on my telescope, do some Mars stuff last year mostly. Then of course I did some Jupiter and Saturn for fun too with the ZWO camera. But first of all, I'm gonna start with sunsets. And I love sunsets. I love photographing the green and blue flashes and purple flashes at times, which are even more rare. Crepuscular, anti-crepuscular rays, as well as these atmospheric turbulence effects you get on the sun as well. I will probably show too many sunset pictures, but I think they're fascinating what you can see with them. So But this was my first sunset picture I tried with my one of the first nights out with my 250 millimeter lens when I got that on a cruise, believe it or not, over the Pacific Ocean. So this is a sunset over the Pacific Ocean. I got this little guy right here. You can see this little thing breaking off the top of the sun. That's called a mock mirage. So sometimes the sun passes through a temperature gradient, a very strong temperature gradient, and this little piece of it will appear to break off and float above the sun for a few seconds. That's a mock mirage. Sometimes they can look green. This one looks sort of greenish yellow, but that's one type of green flash, is a mock mirage green flash. And they're very common when over the ocean, especially when you get that very strong temperature gradient. But I saw this one, that was my first night out, and I sort of got hooked. This sort of picture got me hooked on chasing the green flash and sunset phenomena. And I believe my next picture is from that same sunset. Nope, this is a different one. I'm sorry, this is December 16th, 2012. I thought I put the other one in there, but I didn't. This is actually a double mock mirage. So I got two of them at one time. So one up here and then another one just broke off. Typically when these things break off, they might start off yellow and then they actually will turn green and turn colors. They drift away from the sun. And this one, I think I actually took enough pictures to do a video of so you can actually watch it drift away and turn green. I think I took burst mode of this and did, basically filled until my camera buffer filled up so I could watch, get as many pictures though. And when I take these pictures, I'm literally just sitting there, I'm watching the sun, I'm watching on the live view of the camera, watching for those little things where it looks like it's about to break off, and then hitting the button at that time and doing a burst mode and hoping I get it. Sometimes I do, sometimes they fizzle. Sometimes they're obvious it's going to be great, but it's a lot of fun to see those. I mean, once you practice a little bit, you can sort of anticipate when are these things going to break off? When are they going to break off and turn green? And this one's drifted fairly far away. Some of them drift farther away and others, some only last a little bit. But usually they're green, but they can be other colors. This is actually one from Cerro Tololo Inter-American Observatory in Chile. So about an 8,000 foot mountain overlooking the Pacific Ocean. And this is with my 75 to 300 millimeter lens before I got the 4 and 600. So I obviously a cropped picture of it, but you see multiple green flashes breaking off here. And of course, this top one is still yellow, but it actually turns green as it drifts farther away too. So the sun gets extremely distorted when it gets low in the sky. And Cerro Tololo is an absolutely wonderful place to do sunset photography. So if you get a nice mountain over the ocean, I bet there's some near you as well. If you get a nice mountain over the Pacific Ocean near you, I bet you could get some great stuff like this. I know I've gotten a couple from San Diego, and I'm going to show at least one from San Diego in a few minutes here as well that I got from San Diego, which is even more complex than this. This is a fairly complex one here with multiple green flashes going off at once in multiple temperature versions after. Here's a couple of just a few more random ones I decided to pick up. The one up a little left. One thing I like doing is trying to get the sunset over Kitt Peak, and I got a little mock mirage at the top of the sun as it's set over Kitt Peak here. So I'm somewhere about right here right now. This is from it's probably about 60 miles away as the crow flies. It's on the Mount Lemmon Highway. So I took this picture. So this is the Mayall telescope, the 4-meter, the Bach telescope, and way down here at the south end is the famous McMath Pierce Solar Telescope. Looks like it's sideways 7. This is from Manhattan Beach, I believe, in Los Angeles, if I remember correctly, the top right one. You get a very strong layer, which is actually stretching the sun vertically. Very strong temperature gradient there, stretching the sun vertically. The one in the lower left is an ocean one. I'm forgetting, I want to say this one's San Diego too. Another little mock mirage, much stronger green flash at the top of that one. And then the bottom right one is something interesting called an omega sunset. Sometimes you call it a Etruscan vase sunset as well. Basically, you have an inferior mirage. So as the sun sets, you get a mirage beneath it, an inverted mirage, the sun rising up. So as the sun comes down, the mirage goes up and they meet, making this sort of shape like the Greek letter omega. This one is from Florida. So I know this one's a Florida picture because I get those a lot in Florida when I'm photographing sunset in Florida. My father's retired. He lives in Palmetto, Florida. So I visit him a few times a year and always try and get sunsets and frequently get those omega sunsets. The Gulf with its warm waters is particularly good for omega sunsets. Here's a couple blue and purple flashes. Look very closely. This is another Kitt Peak one, different night though. Right about here, you see a little bit of a blue, just the blue sort of popping out right there. And maybe a little bit of, if I zoom this in really to this full resolution, you might see a little bit of violet or a little pale purple to the right side here too. So you can get blues and purples, and this one's a little bit stronger purple right above there. And you might say, well, why don't we get purple in every sunset? Blue and purple should be the last colors, right? So they should be the last colors as opposed to green. There's a couple reasons for that. One is that our eyes are just not that sensitive to blue and purple compared to green. Our eyes are very sensitive to green, and the sensitivity of our eyes drops off as you go toward the blues and purples. I have never actually physically seen a blue or purple flash with my eyes. I've only seen green, never seen the blue or purple. I've photographed blue and purple, but I've never actually seen them. And of course, also we have talked about a little bit earlier, someone mentioned that you're looking through a very thick part of Earth's atmosphere. And of course, our sky is blue because Earth's atmosphere is very good at scattering blue light. So the blue and purple light gets scattered more. So even when you have a camera, you frequently will have too much scattering to pick up the blue and purple. So only when you get a very exceptionally clear sky do you have a shot at photographing a blue and purple flash. Like I said, I've never physically seen one, but I've photographed multiple ones, and I've seen other people photograph them too, but they are definitely much more rare than green flashes. If I go out in Tucson here, I'll probably get a green flash at sunset, probably about 70 to 75% of the time. Probably about 3 out of 4 nights I try for it, I'll get one. But blue and purple, that's probably more like 1 out of 40 or 50. So it's much, much more rare to get a blue or purple. Now, of course, I should also say, it might seem like an awful high odds getting green flashes 75% of the time, but I've been doing this for a long time, so I've sort of learned what nights are better for getting green flashes. So on the nights they're not likely to happen, I'm not out there. So I'm sure I am loading the dice, so to speak, with that, because like I said, I've done it for a long time. I have a good idea when they're likely to happen. So those are the nights I go out. And I got one last night too. I got a couple of green flashes last night I went out. So I thought last night looked like a reasonably good chance. And there weren't really big spectacular ones, but I got a few mock Mirage plus the last green flash was the sun went below the horizon. So I got about 3 or 4 last night and 1 sunset. Now, there's one thing, I was out one night and I didn't even know you could do this. There was actually clouds near the horizon. I said, oh, I've almost went. I was like, oh, I'm not even going to try tonight because it's cloudy. I said, oh, what the heck, I'm out here, I'll stay, I'll do some photographs. And all of a sudden, when I photographed it, I was quite surprised to find there was a green flash at the top of the cloud. I had no idea this could happen. But of course, I instantly went home and typed in Cloudtop green flash in Google, and sure enough, this is a phenomenon that can happen. So if you actually type Cloudtop green flash, you can find them as well. And I've also occasionally gotten a Cloudtop blue or purple flash. These are fairly rare. You need a nice sharp cloud to get them, but they are fairly rare. But I've gotten them a few times, and now I know that even if there's a cloud, if I look at those clouds and think there's a shot at a Cloudtop flash, I will stay out there. And I have actually seen Cloudtop green flashes naked eye too. So I've actually seen them with naked eye as well. This one I did not see naked eye. I only discovered this one on the camera. And the reason I didn't see naked eye is because there was still this very bright sun poking through that gap in the clouds. I tend to see them naked eye when it's the clouds are solid and you see only the tip of the sun to get that green flash. If you see more bright sun down here, it typically overwhelms your eye and you won't see that fainter green flash at the top. So this one was like I said, just sort of a happy accident and discovery that, it's like, that I've made. It's like, yeah, you can get those. And yeah, there's actually literature out there on them. So I found that extremely interesting that happened, but I had no idea. It's like I said, this is why I call it random adventures in astrophotography, because sometimes I just stumble onto things I had no idea that were possible. And I'm just trying stuff and seeing what I can photograph. And sure enough, something comes out that I find interesting. Now this one is from San Diego. This is one I talk about from San Diego. If you look at the picture on the left here, you'll notice there's a little thing coming off the edge of the sun here. And I noticed that naked eye. Well, not naked eye, but in my camera's viewfinder, I'm like on my live view, I'm like, I wonder what that is. What's going on out there? It turns out there was actually a ship in the water right at that point, right next to the sun. And the hot exhaust from the ship's smokestack took that sunlight and bent it back to me. So if you actually do the ray diagram, figure out hot air, which way is it going to bend the light? Light's going this way, hits the hot air, it bends. So you get this little streak going over to the smokestack from the sun. So that's actually refracted sunlight from the sun. And I've gotten this a couple times, not just from ship smokestack, but in Tucson, I got it with an A10 near sunset that flew across the face of the sun one time. So I got this nice little streak of the refracted sunlight connecting the A10. Looks like the A10 has these flames shooting out the back of it, which is pretty spectacular. I've gotten it from a couple of helicopters that have crossed the face of the sun when I've been photographing. So again, if you do it long enough, you start getting dumb luck and good timing. So again, this is just dumb luck and timing. I had no idea that ship was there. And then of course, this is the same sunset. The picture on the right is the same sunset, And there you can see the ship's smokestack, that black vertical little line there. And you see the green flash is the last bit of the sunset, the sun is setting, but also refracted yellow sunlight from the sun, which is now below the horizon. But that hot gas is, again, bending the sunlight and making it look like it comes from above the horizon. So that's a very strong refraction effect right there from that hot gas. So that's a very interesting picture. And when I was photographing this, I did not realize there was a ship there. I did not know there was a ship there until after I started looking at the pictures. And I saw the green flash naked eye and this little yellow thing sitting there. And I'm like, what is going on? Because that little yellow thing, that little yellow piece of refracted sunlight hung in the air for about 30 seconds after the sun set. So I'm sitting there taking pictures saying, when is this going away? When is this going to end? So it was amazing how strong that refraction was from a ship's smokestack right there. So I had no idea that there was what was going on when I was actually physically looking at these pictures. Do I have any comments or questions from the chat? Someone says, what do you mean by noise? I'm not sure what that question is about. Does anyone know what that question is? It says, administrator to me, direct message. What do you mean by noise? Oh, okay. That must have been from back when I was talking about the camera sensors, right?
Yeah.
Okay, that must have been back when I was talking about the camera sensors. Okay, noise, I'm talking about electronic noise. And typically with bigger pixels, you get less noise. Smaller pixels, they're close together and you get more electronic noise and crosstalk between pixels and that sort of thing. Bigger pixels, you tend to get less of that. So that's what I mean by camera noise. So and you can see that by graininess in the camera sometimes. So, okay, so I wasn't monitoring the chat that closely and just saw that picture. So, and there are of course ways to deal with noise and processing. And professional astronomers, a lot of even amateur astronomers are, I hate calling them amateur astronomers because some of them are so good at imaging that it's, would have easily been professional quality imaging 15 years ago. And some of them do so much amazing stuff. I hate calling a lot of these people amateur astronomers, but they'll do things like take dark frames. You take a picture, it's a 2-minute exposure, take a 2-minute exposure with the camera covered, and that'll show you what the noise is, and you can subtract the noise out. That's one way of dealing with this. Various ways of dealing with noise that deals with your noise and hot pixels and that sort of thing. So there's ways to deal with that in post-processing, and Photoshop and Lightroom have some noise reduction things, some of which are more appropriate for astrophotos than others, depending on what you're trying to do. But they will definitely smooth out some of the grain sometimes. There's actually a solar eclipse. I think this one, I didn't mean to put this one in this order, but we'll talk about it now. This is one of my favorite. I put this here because it's still sun, that's why. This is a solar eclipse from July 2nd, 2019. It's the Chilean solar eclipse, which passed right over Cerro Tololo Inter-American Observatory in Chile. And this is the SMARTS 1.5 meter telescope. I forget what SMART stands for, so don't ask. It's an acronym, of course, but I forget what it stands for. It's a 1.5 meter telescope. And me and several of the other professional photographers, and these were professional photographers, I'm not quite as good as they are, but we all set up our cameras to this spot because we wanted to get the eclipse sun with this dome to the side. And I wish I had just a little bit wider lens, should have gone just a little bit wider. But this is the eclipse taken every 2% of the eclipse, layered in Photoshop, of course, with a longer exposure during totality to bring out the foreground objects and stuff. So that's a very nice image. This was done with a program called Solar Eclipse Maestro. It's a program for Mac only. It's not available for Windows. And unfortunately, it's only a 32-bit program, so it only runs on older versions of OS X. But it was a great program, and that's a nice thing about this one right here is I did not have to touch the camera for this entire sequence. I just hit start a few minutes before the partial phases. The only thing I had to do was make sure that the solar filter was taken off during totality and put back on after totality. And the camera took every one of those pictures on its own, other than that. So, and I was able to take them and layer them in Photoshop afterwards, and that was great. So program Solar Eclipse Maestro. There's also a Lunar Eclipse Maestro by the same person, which is, again, only a 32-bit program. I used it for previous lunar eclipses, but I cannot use it tonight because all my current Macs are on the more recent operating systems, which only let you use 64-bit programs. But it's a very nice program, and I hope he eventually ports it to 64-bit. Did I hear a comment or question coming in there? Thought I heard someone say something. All right, this was a very, very interesting eclipse because of Cerro Tololo. We have our observatory there, so we had a big event for VIPs down there, and Kip Thorne was one of our guests. He's a Nobel Prize winner for the discovery of gravitational waves a few years ago. And I also was working with a group from the University of La Serena in Santiago, University of La Serena there, several students, and another one of our colleagues in Chile, Juan Sigel. He's a Cerro Chololo employee. And we actually set up an 11-inch telescope, 8-inch telescopes when I use, but the 11-inch telescope, and took pictures of stars near the limb of the sun to attempt to reproduce the Eddington experiment, which is where Sir Arthur Eddington led the expedition to look for the deflection due to the sun's gravitational influence to attempt to collect evidence for Einstein's theory of general relativity that gravitational influences can bend starlight. And of course, Eddington did find that, and it looks like it's been a long time analyzing data, but I think we got it too. It's very close. We're still working on data, but almost 2 years later, of course, the pandemic and stuff is taking that out, and we've had some other issues along the way. But you know, college students, they don't always meet the deadlines you want them to, but we're letting them do most of the work. But we think we just got some of the more preliminary data. It looks like we got it. We're trying to do double checking right now and verify that we really did, but we think we got it. And the goal was to do this in the 2020 solar eclipse, which passed over southern Chile. But of course, we know COVID hit and we did not get to travel to that one. I was supposed to go back to Chile for another solar eclipse, and unfortunately, COVID killed that one. But I've actually looked at the weather forecast, the weather for the place we were going to observe from, Lake Villarrica in Chile. It was totally cloudy and raining that day. So we would have been totally rained out if I was there. So somehow that makes me feel not quite so bad. But so I'll move on though. Another little topic here. Another thing I like is things you can barely see. They're not always the visually impressive, but hopefully interesting subjects. And sometimes just wonder, can you get this with the DSLR and a zoom lens? And yeah, there might be other people in the world who take better pictures than me of these phenomena, but I can guarantee you no one takes pictures with smaller equipment than I do. And I do have a star tracker. I have 2 star trackers. I have an Ioptron star tracker and the Ioptron Sky Guider Pro. I got the star tracker first because it came out first. And the Sky Guider, when I started using those heavier zoom lenses, I got the Sky Guider Pro because it has a heavier weight capacity. It can carry the bigger lenses. So I upgraded to that when I got it. I still have both of them, so I can still use both. Still have two cameras guiding at once if I so desire, as long as one of them has a smaller zoom lens on it. But this is one that I did several years ago. There's a supernova in M82. So you might recognize this field as M81 and M82. And this little bright spot in M82 right here is a supernova that went off several years ago. That's a Canon 60D. That's before I got the 80D. I had a 60D, and then it's, the board on it got shorted out when a screw came loose inside, so I had to upgrade to the 80D. That's my 75 to 300 millimeter lens on the Sky Tracker. And I got a supernova, single star, exploded 10 million light years away. So I'm sure people got better pictures, but I can guarantee you no one got pictures with a smaller telescope or smaller piece of equipment that. And I think that was only a 30-second exposure, if I remember correctly. So that's a very short exposure. You can get the 2 galaxies plus that little lens, that little guy right there. I would have loved to have had that 600 millimeter lens at the time to try it with that. So I'm sure that would have pulled in a little bit better, made things twice the size, at least give me twice the magnification. Plus, I have a camera with more pixels, getting more pixels on this image as well. So, and this is one I did several years ago. This comet sighting spring in Mars. You might remember this comet passed within a few million miles of Mars one night. And right at the tip of this little arrow here is this little blue dot. I don't know if you can see it. I can see it on my screen. This little blue dot is comet sighting spring as it passed by Mars. Again, that's about a minute exposure on a 60D with the Sky Tracker. And I said, people got some nice images of this. Mars, of course, way overexposed because the comet was, I don't want to say 12th magnitude around at the time for that. So it was not a very bright object at all. So it's a fairly faint comet, but I got this and just a fun little thing. I actually got that on Kit Peak. Can't remember what the event was, but I was on Kit Peak that night and I was actually working some event. So we had some star party, some group up here I was working, some VIP group. And I snuck away from them for about 10 minutes when just did a quick polar line to the Sky Tracker, threw the camera on there and took this picture, and I had to run back to the group. So I just had to very quick break, do this image. So I was very happy to just have that shot to get this one, even though I said it's not the most visually impressive, but I'm still quite happy that I actually got it at all. Sometimes just getting it is the goal. Sometimes just getting something is the goal. And I was happy to get this one. And there's another very challenging one right here. As of twilight, shortly after twilight, we had Venus in Vesta. And I said Vesta. This was the first night when I made this picture. There's a little dot right above the T. Look very close to the little dot right above the T. That's 82 Gemini right there, the star 82 Gemini in Venus. And I said, is that Vesta? And I was like, yes, that is Vesta. I verified the next night. So I went out and took another picture, and I could see that was the one object that moved in this picture. So I was able to verify that was Vesta. Unfortunately, I don't have that picture in this presentation, but I was able to verify that was Vesta. So I was able to get Venus and Vesta. And this was a very tricky picture. The sky was still so bright. If you took too long of an exposure, you'd overwhelm Vesta. The sky brightness would be too much. Took too short of an exposure, you wouldn't expose long enough to get Vesta. So there were dozens of pictures I took trying to get this through power lines. Of course, you can see right here, there's power lines in my way too, from where I was that night. So I was dodging power lines as well as trying to get the exposure just right. And there were a couple pictures in the middle there where I got Vesta, but a lot of them was either too faint or the sky overwhelmed it. So it took a little processing, teasing it. And some people ask about noise too. If you look at this picture, you can see noise in there as well. You can see the sort of grainy appearance, especially toward the top. Get some noise in that picture there, that electronic noise I was referring to earlier. One thing I've also sort of gotten into is I like taking pictures of conjunctions of interesting things. So I do some conjunctions of Neptune here. So I have 3 different pictures of Neptune. I believe this is Venus and Neptune, right at the top here, so top left. Mars and Neptune is the right picture. And then another Mars Neptune one at the bottom here. This is Neptune right up here. I did check this just to be sure I remember which one was Neptune in this one. So getting pictures of planets together is another one. It's getting those Uranus and Neptune conjunctions. I've done several Uranus ones too with Venus and Venus. I think can't remember if I got Mercury and Uranus or not. But Mercury would be a tough one because it's only visible fairly close to the horizon, so it's a tough one. But I would love to get all the planets with Neptune and Uranus together, but it's not at one time, of course, but over the course of time. That'd be a fun thing to try for. But I don't think I'll ever get Neptune and Uranus together because they won't be in that position, their orbit in my lifetime. So I think that one is sort of out of the question. But I'd love to get the collection of all the others. So there's another one I've got, one of my very favorite pictures. Again, very challenging one. One of the thinnest crescent moon I've ever spotted. It was less than 14 hours old upon spotting. It was 13 hours and 46 minutes old when I first spotted it with binoculars, not naked eye, but I saw it through 8x42 binoculars. And this is from Cassiopeia Observatory, just north of Tucson. My friend Mike Wiesner, who just published his autobiography. If you want to look him up and see that, he has a nice little observatory up there. And we were out there on January 1st of 2014, to be specific. It was New Year's Day, very young moon. And I saw an article on Universe Today. It said, hey, people in the Southwest, you got a shot at seeing this moon. So I told Mike, I was scheduled to go out and see Mike. And he said, hey, you want, well, I said, so we'll try this. We said, sure. So we've got our binoculars and telescopes out and cameras ready to do it. And I was the first one to spot it. And he got it just after I did, after I point out which tree to look at this tree and go up. And he found it too very quickly. And then we, of course, started snapping the photos of it. And if you look at the Universe Today website from around January 2nd of 2014, there's a nice little write-up on there that they did about Mike and I and featured our pictures on there. So this is a very fun one. That's my record for new moon sighting. And if you, of course, read Sky and Telescope, I believe Stephen O'Meara holds the record for naked eye sighting at, I think it's 15 hours and 2 minutes. There are a couple people who have done telescope and binoculars newer than this, around 11 hours, but still, I'll take this. This is definitely a challenging observation, which I was very happy to get, and quite proud of that picture. So it's a lot of fun doing. I've done a few other new moons since then. I've tried to get under 13 hours. I've tried a couple that are around 12, but not been successful on them so far. But I haven't given up. Next time I get an opportunity to see one that's less newer than this from my location, I will try. Of course, you need a nice clear sky and a clear western horizon to get them, and a little bit of luck. Not just a clear sky in terms of no clouds, but hopefully clear in terms of no pollutants, like you said earlier, the volcanic eruptions and that sort of thing, low humidity, all that stuff can hinder the view near the horizon. So you do need a very clear sky to get these things, but it is a lot of fun. So that's another one of the things I keep an eye out every month and say, oh, what's new moon this month? And see how many hours after new it is around sunset here. And if it's close, I'll go for it. That is a little fun thing I try to do. And of course, interestingly enough, I've also tried moons that are 15 and 16 hours old and not gotten them. Again, because the sky has to be very clear. So I've actually had moons that are a couple hours older than this that I have not successfully gotten. So sometimes just I get just the right conditions. Okay, and this is a fun one I got too. I like crepuscular rays. I sometimes take pictures of them after sunset, those rays that appear to emanate from the sun. And this one is an interesting one because you can also get anti-crepuscular rays, which appear to converge on the opposite horizon from sunset. And this one, I was out one night watching sunset, and I saw these spectacular rays. Crepuscular rays can literally go all the way across the sky and converge at the anti-solar point. And I was seeing these naked eye vision thinking, wow, this is spectacular. I wish I had a fisheye lens with me. And I suddenly realized, wait a second, I think the fisheye lens is in my bag. So I ran to my car as fast as I could. I was about 10 feet away, but of course did that comical cartoon thing where your feet start going too fast and you're trying to run, to grab that lens and get on my camera and actually photograph this, and took a bunch of photographs of different exposures, try and capture them. This is the one I like the best. We can see the rays start over here by sunset, and crepuscular means before, at dusk, basically, either early in the morning or right before sunrise or right after sunset. I just saw that question in the chat there. Crepuscular. I mean, some animals are crepuscular animals. Animals that are crepuscular go out and hunt right before sunrise or sunset. We're, of course, diurnal, and then, of course, you have nocturnal animals as well. But crepuscular is the ones right before sunrise and right after sunset. And so I thought this was really neat, seeing these rays that actually converge. So obviously there's some clouds on the horizon. If you look very close to western horizon, you can see some clouds just hugging the western horizon here, which of course what caused the rays. And then of course, since the rest of the sky was clear, you had this great vantage point of getting them going all the way across the sky. Of course, with some telephone lines in my way. I was actually out to photograph a green flash that night for sunset, trying to do some green flash photography, and got a very different picture. And you might notice this little white dot here, this little white dot to the right, that is the moon. So that is the moon. And some people don't realize just how small the moon really appears in the full sky. But this is, you can see the full sky at once. That is the moon in the sky. So it's actually very, very small. And I actually, Phil Plate, the bad astronomer, did a blog entry on this picture as well. So if you want to read about this picture more, he does a very lengthy explanation of crepuscular and anti-crepuscular rays that are very nice. And of course, believe it or not, these are actually parallel lines. So they're kind of like lines of longitude, but they're on a non-Euclidean surface, they can converge. So like crepuscular rays are actually parallel when you project it onto that surface. So it's all non-Euclidean geometry. It's very complicated, so don't ask me to explain it. But Phil, like I said, Phil does a much better job of that than I do, but he did a nice blog entry on this as well, because we were actually just on Twitter one time and he made a comment about crepuscular rays. So people were talking about them. And I said, I just posted this picture as a reply to one of his tweets that, and you can see them all at once. And he'd never seen a picture like this that captured them across the entire sky. So he said, I have to do a blog entry on this. And we're old friends. I've known him for a long time. So like, of course you can do a blog entry on this, and send him the good full res version of the picture so we could use that. But I just love this because I can see the whole thing at once. I've gotten other times where I've seen single crepuscular rays or a couple go across the sky, but never this many going all the way across the sky. So that is definitely a rare shot. And I've searched the web to see if I can find any other pictures like this. And I've seen no other pictures of someone captured this with a fisheye lens going all the way across the sky like this. So if you see one, I'd love to see them. If you find one of those pictures, I'd love to see it too, because I'd love to see other examples of this phenomena. I think there would be some, but I've not had any luck finding anyone else who's done it. Now, another thing that I showed my last time here, well, Jeff Adkins showed it when I was Parallax presentation a few months ago, is International Space Station transits. That's when the ISS passes by the sun or moon are the two most common objects, but you can do planets as well. And I actually have done a couple planets. Just last fall, I started trying to catch it by planets, and I've got a couple of those as well. Timing is critical though. The ISS moves fast. It can take, depends on the exact geometry. It can take less than a second to go across the face of the sun or moon, or it can take up to 2 or 3 seconds if it's low in the sky when it appears to move slower across the sky. But still, even with a few second window, that timing is fairly critical. There's a website called transitfinder.com where you can enter your latitude and longitude, and it will show you transits near you. For if the transit is very high in the sky, you might have to be within about a 3-mile, 5-kilometer wide path to see it. If this transit is low in the sky, you'll have a much wider path where you can actually see it on the surface of the Earth. So it varies depending on how far away the station is. There's also an ISS transit app for Android. And I like the ISS transit app for Android because it shows you transits of planets as well. transitfinder.com on the web does not show you transits of planets. Only the Transit Finder app shows you that part. So the ISS appears largest when it's high in the sky and it's very close to us. When it's low in the sky, it's much farther away. So it can be about 400 some kilometers when it's straight up. It can be over 1,000 kilometers, 1,600 kilometers when it's very down low in the sky. So I usually take a video of mine, and most of the pictures I do are actually with my camera and zoom lens, that 150 to 600 zoom lens. My Canon 80D has a digital zoom feature on it. And you might say, I know they always say, never use digital zoom. A lot of people tell you that, never use digital zoom. But in this case, it actually doesn't work too bad. It actually works really well because it's a 24 megapixel sensor. But of course, it only takes HD video, which is only 2 megapixels. So instead it just takes a smaller portion of that pixel, that sensor, and uses that to create the video. So you really don't lose resolution in there. So I usually use about a 3x zoom factor, digital zoom, along with a 600 millimeter lens on a crop sensor. Well, 600 times 1.6 is about 980 millimeter focal length for equivalent to 35 millimeter camera. With a 3x digital zoom, I'm operating a touch short of 3,000 millimeters with that setup. So you can actually get some pretty good detail with a 3,000 millimeter setup. So, and here's my very first ISS transit. We actually had a sunspot there at the time too. I should go back and remix this one because I think I could get that sunspot a little bit sharper if I aligned the images a little bit better. That's something I didn't learn how to do at the time, but now I know how to align the images a lot better. But this is the first one. It was about an 8 a.m. transit, so fairly early in the morning. So the sun was not terribly high in the sky. It was my first one I tried, and I got it. Did the video, extracted the individual video frames, and layered them in Photoshop to get this image. I want to say the distance this transit was probably about 650, 700 kilometers. I'd have to look up the exact distance, but it was in the 700 kilometer-ish range, roughly. And of course, this is my first one. I didn't realize how much bigger the station got when it was actually at a close pass. Now to get a close pass, you want it high in the sky. So you want to take an image near local noon. And of course, the higher in the sky you are, the better. So for Northern Hemisphere observers like us, that means Northern Hemisphere summer. So Northern Hemisphere summer near noon is when you're going to get the best transit. Of course, they don't always transit the sun at that time, so you don't always get that many chances at it. But fortunately, I did get one. Oops. Oh, I'm sorry. This is the video. This is the video of that first transit. Just to show you how fast it can happen. And I'm going to advance the video here so I don't have to wait quite so long. You can watch the transit and it's going to go right. There we go. Did you see it? See the transit? People see it or not? Just curious how many people actually saw it. Because it is a fast moving little guy.
Yeah, I saw it.
Okay, so some people did see. I'll do it one more time for people who might miss the first time.
It goes from about 2 o'clock down to
Yep.
8 o'clock. Yeah.
Yep, exactly. Right in there. So right on target. So that's the video of the transit. So as you can see how fast you do have to have it going fairly quick. You have to be fairly well in the timing. Of course, I will say these transit apps, they are spot on. I have never missed a transit due to a timing error. So they are spot on. I've looked at my GPS synced watch and they are just, to the second almost. So that's not what I want to do. I want to actually advance slide here. So let's see if I can, there we go, advanced slide. So this is later that summer. I got a very close transit, 436 kilometers. This was taken about a little before 1 o'clock local time in Tucson in early August. So the sun was very high in the sky. And this is an interesting shot because you can actually see the solar panels were in a different configuration than normal. You see solar panels on the left, but the right ones are tilted so we can't see them. They're actually edge on to us. Most of the time, the space station looks like a little TIE fighter. You see both solar panels. But occasionally, when they're bringing in another shuttle dock or a capsule dock or something, they will tilt the solar panels on one side to clear room by the docking port, and you'll get an interesting shot like this. I didn't know this at the time. I was like, why does the station look different all of a sudden? So I had to go look up why the station looks different, and that just was lucky. And I saw someone else recently put Cosmic Background Studios. They have a great Facebook page. They recently posted a picture of an ISS transit where it's in a similar configuration to this. And he went to that same explanation about how they had the solar panels tilted. I think that was that might have been one of the recent Dragon missions. I can't remember for sure because it's fairly recent. thinks the Dragon capsule is going to dock, so they tilted the panels on one side. So we got an image that looks similar to this. And he actually uses a much bigger scope than mine, and got an image that looks similar to this because I'm pushing my little setup to such extreme focal lengths. So his is better, but still, mine's pretty good considering I'm not using nearly as fancy equipment as he was. So you also get lunar transits, and there's 2 different types of lunar transits you can get. The one on the left, the actual ISS is in daylight. So you see the ISS little dot, and this is actually a fairly distant transit, so you don't get any detail in the ISS. This one was a fairly distant transit. I think the ISS might also be a little overexposed there. I see image of that ISS. Could you blow up an, oh yeah, could you blow up an individual image of that ISS? Yes, I could. I haven't done it for this, but I can. I basically just crop it down as far as you can go, and then I'll bring it out. But I have done that, so but I haven't done that for this particular presentation. I think I can find a picture of it though, if I might have from a previous presentation that I can look up here. Let's see, do I still have that one called up or not? I'm gonna go to my I still have it called up or not, I can't remember. Yes, I do. As many of us do, we sometimes steal from ourselves. And there's a different presentation I did on astrophotography where I actually did blow up an image of this one here. So this is, let's see if I can get this one to come up full screen here. And there's too much stuff in the way here. Yeah, I want to present that. So there's actually the highest resolution I can get of that International Space Station there when it's actually blown up. 1 pixel equals 1 pixel. So that's that. So that's the highest resolution. I took that and just went down to the pixel level. That's the detail I'm getting on the ISS at this point. So, thank you. I don't mind taking. Did that work? Did you see that image okay? Not seeing it. Okay.
I don't think you're sharing that screen.
I'm not sharing that screen. Okay, I'm going to stop sharing that screen, and then I'm going to go back and reshare that screen. So hopefully that still work this time. Are you seeing it now?
Yeah, now we can see it.
Okay. So that's the best I can do with 1 pixel equals 1 pixel. So this is a picture I created for a different presentation in the past. You can definitely see that there gets nice, reasonably good detail there. So love to be able to sharpen that up a little bit more. But for a camera and a zoom lens, I think that's pretty darn good. Stop sharing this screen and go back to sharing the other screen now, since I didn't realize that wouldn't transition automatically like I wanted it to, but on you.
I have a quick question. When you're doing the photography of the sun with the regular camera lens, is there any kind of special filter you're using?
I'm using a Vader solar filter. Yes, good question. I'm using a Vader solar filter. And how do I just start this? So, which is I got from Amazon, which is a very nice little there, play from current slide. That's why I got on Amazon. It's like $30 or something like that, and it's an adjustable filter. So you have little screws on the side. You can adjust it to fit different size lenses. So that's an interesting thing. I actually got that in 2017. It's a Solomark solar filter. They're a good company. They've been around for a long time. I got it for the solar eclipse in 2017. And then a few weeks after I got it, I got an email from Amazon saying they could not verify that was a safe solar filter and I should not use it. And they actually offered to refund my money for it. And I know a lot of photography, and I had to look up some tables and said, well, an ND5 Vader solar filter should be properly exposed if you set this f-stop and this exposure. So I went outside and set that f-stop and exposure, and my camera got a good exposure. So I to conclude that was probably a good filter. And we also have a Spec 20, no, what is it? I can't remember the name of the instrument. We have those instruments downstairs at our Noir Lab, which you can put a filter on. It'll measure the transmission of the filter. So I found someone who runs that instrument. Said, hey, can we measure this filter? He said, sure. We put it on there and found out that its transmission was exactly as it should be. So it was a legitimate Vader solar filter. We have a nice transmission graph from it as well, which is pretty cool. So I was able to actually check that one. I realize not everyone has the access to that facility to just be able to take their potentially counterfeit filter and check it, but I did, so I was confident that filter is good, and I've done a lot of solar photography with it and never had an issue, so I'm concluding it's a good filter. Now, planet transits too. I can also do planetary transits. Last fall, I found that the ISS was going to pass by Saturn. So I did a Saturn transit one night. This was not nearly as close a pass, so the ISS looks a good deal smaller. And on the right, this was in November, so Mars was well past opposition and shrinking in our sky, but we did have a Mars transit as well. So I got the ISS right by Mars. This one I didn't do the composite image, I just did a single shot of the ISS by Mars. So if you actually get the images, you can do Saturn and Mars. I tried Jupiter and I cannot remember. Jupiter was the first one I tried and I got it. You know, you could see it, but I just wasn't happy with the image. It wasn't quite as well focused as I wanted to, so I didn't really play with that one as much. But I got it. It just didn't make me happy the way it came out. So, but these two I was reasonably happy with the way they came out. You got, you know, the ISS is bright and you got to get the exposure just right, so you don't try not to blow out Mars or underexposed Saturn, and it's a little tricky sometimes. These exposures with objects that are very different brightnesses. So planetary transits are also possible, and there was an APOD last year which someone did a really spectacular ISS transit to Mars. That made me think I have to try this. So his is better, but still I was happy with what I got. Of course, he was using a much bigger telescope too, and I was using my camera and a zoom lens. So, and this is one of my favorites of all time. This is what I was really proud of, Bepi Colombo. It's a satellite that was launched by the European Space Agency to study Mercury. And as you know, a lot of times when you launch a satellite to visit our inner solar system like Mercury, you need to do at least 1 or 2 gravitational assists to get you there. And it did gravitational assist to fly by Earth in April of last year, April of 2020. And this was during lockdown, and I thought we were up to short after COVID, and we were all working from home. And I thought, I'm going to go out and try this. And heavensabove.com, a lot of you probably are familiar with that website. They had a very, very precise table that showed you the RA and deck of the satellite from your location. If you put in your location, which I could work Tucson, every minute. So this thing was moving a couple of degrees per minute. So you had to have the position extremely precisely. So I took my telescope out, and this one I actually used a telescope. This is an 8-inch telescope. Although based on how bright that is, I probably could have gotten that with my zoom lens, with my 600mm zoom lens. But my Celestron 8, Nexstar 8 f10 telescope. I think I did not put the focal reducer on. This is my Canon 6D camera. So the full frame camera gives about a degree field of view. And I went out there, and the satellite was actually in Earth's shadow for a while. And this is just after it came out of their shadow. The picture on the left is within a minute after it emerged from Earth's shadow. So it emerged from Earth's shadow in the southern sky. It was not very high. It was a little over 20 degrees in the sky when it first emerged. So it's not very high in the sky. And that's the picture I got. I slew my telescope where it's predicted to be. At the predicted time, I hit the shutter for a 20-second exposure. That's a 1 degree field of view. So in 20 seconds, it's moving a third of a degree roughly. So it's moving about a degree per minute. So it's moving fairly quickly. And there was a nearly full moon out that night too. So the picture on the right has a nearly full moon. That's why I see so much. That's why there's 2 interesting things about the picture on the right and left. The left picture is the first one within a minute after coming out of the shadow. The one on the right is about 40 minutes later. And I tracked it for about 40 minutes roughly while I was going across sky. You can see that the streak length is much shorter because the satellite's farther away, so it appears to be moving much slower. And you can see the sky is darker. These same camera settings, same processing, and that's because it moves so much farther away from the moon. This was fairly close to the bright, almost full moon at the time. This is much farther away in the sky from the moon. So you can see how much the sky darkened just by it moving farther away from the moon as well, which I found to be an interesting phenomena. Bottom picture, I also had my Canon 80D with a wider angle lens, just taking a bunch of exposures, and I hopefully you can see the streak down there at the bottom one as well. I'm having a hard time seeing. Yeah, I see the streak now. There it is. Yep, right here. So I just layered those pictures, but I can't remember what those exposures were, 20-second exposure, maybe 15, 20-second exposures. Layered a bunch of them together too to get that little streak down there of that satellite. There are a couple gaps in the streak, and I'll admit that the gaps were because I was impatient. I was wanting to see if I was getting the camera, so I stopped taking pictures for a second to review one of the images to see if I was actually getting it. So those gaps were strictly me being impatient. So I know what they caused. They weren't any malfunction. They're just me and my my natural impatience and giddiness of getting these images. So, and sometimes, of course, it's where you are. Sometimes the foreground is what makes the image. And there's this great app I use, and I'm actually using it to plan tonight's eclipse images. I'm going to go outside with it afterwards and walk around the mountain. and set it to the time of the lunar eclipse and in the morning at totality, and see where the moon will be from various spots on the mountain, or what telescope will it appear over. It's called PhotoPills. It's available for Android or iPhone. It's similar to the Photographer's Ephemeris, if any of you use that program. It's a paid app. It costs about $10, but I've had great luck with it. Excellent app. It has a VR mode, so you can hold up and see say, this time, where's the moon? And then you can hold up and see what's in front of the moon at that time. So it's a really neat little app you can play with like that and do a lot of fun stuff with. You can also use it to find, you also use it to find things that are much farther apart. Like for instance, I can be in Tucson and say, okay, what day is the sun going to set over Kitt Peak? I can put a pin at Kitt Peak and look at where the sun is setting, and then the shows the line of sun where I am, shows the line goes sunset, and then move around till I find out where the line of sight from me to Kitt Peak matches line of sight sunset to Kitt Peak. So I get the sun setting over Kitt Peak, and that's how I frame some of my images. So it's a very useful program. I highly recommend it. It's a great, well spent $10 in my opinion for what I've used it for. And one thing I used it for last summer was to get Comet Neowise over Kitt Peak. So these are Comet Neowise high in the sky. Unfortunately, Kitt Peak was not open to the public during the summer, and last summer we shut down hard. Boy, did we shut down hard. I kept telling the administration I wanted to go up Kitt Peak and get pictures of Neowise over Kitt Peak, and they kept saying no and no and no. So I tried for weeks to get them to let me go up there, and they would not let me do it. So this is actually from the road that goes down to Buenos Aires National Wildlife Refuge. So it's probably about 15 miles from Kitt Peak roughly. But I was able to, had to drive out here, drive south a ways in the middle of nowhere. Border Patrol agents driving past me all night, asked me what I was doing. I had 3 Border Patrol agents stop me and ask me what I was doing out there as I was trying to get these photos. But if you see the little telescopes over Kitt Peak right here, and Comet Neowise over Kitt Peak. But I actually found that spot to get these photos by using PhotoPills, by finding out what the azimuth of the comet was, find out the azimuth of Kitt Peak from these various locations, and picking the one that I could get Neowise over Kitt Peak. And of course, Neowise was such a treat last summer, and I was very happy to get these photos because I didn't see anyone else get photos over Kitt Peak. You had to go to a fairly remote location to get these. And like I said, there's definitely nothing out there. So possibly between all the border running that goes on here and the wildlife, probably wasn't the safest place in the world to be, but I'd go for those pictures sometimes. And of course, I got this one, again, using PhotoPills, a crescent Venus. If you look to the left here, there's a little crescent Venus. And this one, again, there's Kitt Peak here to the right. This one zoomed in quite a bit, so you see the telescope's a lot better. This one I could not, would love to have gotten Venus directly over Kitt Peak here, you know, more over Kitt Peak, that crescent Venus. The problem is that sometimes roads don't go where you need to be. This was taken from near Mount Lemmon, from the Mount Lemmon Highway. And unfortunately, there's a road here, there's a road way over here on the other side of Mount Lemmon, and I need to be somewhere between those 2 roads to get Venus over Kitt Peak. So I could not actually drive to a place I could do this image. But that's the closest I could get, but I'm still happy to get that fun little image of a crescent Venus over Kitt Peak. Again, my 600mm lens, you can actually see the crescent shape of Venus there. So I wanted to be able to get that one and see that. So I would have loved to have gotten over Kitt Peak so I could have cropped and gotten that in more pronounced crescent Venus, but just the roads didn't go where I needed to be, unfortunately. Now, lunar eclipses. These are fun lunar eclipses. This one in the left here is the one in Las Vegas. Again, this is just sort of getting I talk about how sometimes the foreground object's what makes it. This is Las Vegas. It's that lunar eclipse I talked about before, that was the one that was that controversial one that was supposed to be total, but I'm never convinced it quite was, and not a lot of other people weren't convinced either, because we always saw that little part of the moon lit. But I just was in Las Vegas, and this was about a little before 4 in the morning. I think it's 3:45, 3:50 in the morning, and getting it over the Luxor Hotel where I was staying. So sometimes you use what you got. And the one on the right is the January 31st, I believe it was, 2018 solar eclipse from Kitt Peak with the 0.9 meter telescope. I was on the roof of the 2.1 meter telescope taking this image at the time. So that's why I almost said the 2.1 meter telescope. But this also where we saw the Selenalila, and however you pronounce it, make sure I get where the setting eclipse moon was in the sky at the same time as the rising sun. And so that was a very spectacular night to do that one too. So my colleague got a great composite picture of this. He was very patiently doing a composite image that night, I was doing more close-up stuff. So we had two different types of photography going on at the same time that night. So I also enjoy sun halos and atmospheric optics. And those are kind of fun things. The one on the left is just one I took with the palm tree. Sometimes you get the palm tree in the middle of this halo. Sometimes you want to put something there so you block out the very bright sun so that you can get the halo nicely. And the one on the right, of course, it looks like a more complicated image than it really is. You just put your cell phone in selfie mode, put it right in the middle of the shadow of your head, and you know it's going to be your head's going to be centered on that halo. So it's a very easy, fun self-halo picture to take that I enjoyed doing when I first found out that one years ago. So it's a very fun little selfie halo. I tried it with the moon halo recently, but a moon halo is much darker, so it's darker at night, so you don't get nearly as good image of your face with the moon halo. But I did do it. I got it. I don't know why I didn't put that one in here, but I forgot about that moon halo one. But I do have there's more complicated optics. Okay, so there's a little more complicated. There's more going on here. So we do have our sun halo, fairly weak halo. We also have two sun dogs. Sun dogs on opposite sides of the sun here, little bright spots on opposite sides of the sun. And on top of the sun here, this was taken last winter, I want to say around November. We also have what's called a upper tangent arc. So this is sort of, this arc here sort of is tangent to the halo. So it's called an upper tangent arc. And then an upper peri arc, this other arc that is sort of, we have one that's tangent arc. It's the opposite of the almost mirror image of the tangent arc. So I also saw a circumzenith arc, which was up here, but that circumzenith arc disappeared before I got my camera out. I literally saw this display of optics and ran inside to grab my camera, but things changed before I got my camera back out. And this is that very wide angle fisheye lens. And the reason I use such a wide angle lens is I was trying to get this upper zenith arc up here, the circumzenithal arc up here, which goes literally, as name implies, around the zenith, the circumzenith arc. So, but unfortunately that one disappeared before I got my camera ready. So I didn't get that one, but I still got the other ones with a fisheye lens. And I said, I love moon halos too. So moon halos are a lot of fun as well. So here's just a couple examples of moon halos. First one, the left one, I put some foreground trees in to make it a little bit nicer there. The right one, this is Mars right here. This bright object Mars was actually inside the moon halo on this evening. So that's a fun one too, just get Mars inside that one. And again, all these halos and atmospheric phenomena are caused by ice crystals in Earth's upper atmosphere, usually hexagonal ice crystals, hexagon-shaped ice crystals in Earth's upper atmosphere. So these are very fun objects. How much time do I got left, David? How much time do I got left?
Well, you got plenty of time.
Okay. And I know I've been going for at least an hour here. I don't want to bore people to death, but
No.
I could talk all night, and I'm sure if I start taking questions, I could talk for even longer. So I'm sure I'll have interesting questions and comments. So
Right.
I see a couple things in the chat. I don't know if any of them are things I haven't addressed yet.
That's a good one.
Oh, you're talking about the Erdos-Bacon Sabbath number?
Mhm.
I saw someone asking about that special number there. Okay, yeah, this Erdos-Bacon Sabbath number. That is a fun number, and not a lot of people have done things to get an Erdos-Bacon Sabbath number. So, but here's a fun picture I have, which I've got moon dogs. This is the only picture I've ever gotten moon dogs, just like those sun dogs. You can get moon dogs and sun dogs without having a halo. Tonight we just got the moon dogs without the halo, depending on where the ice crystals are situated. But this little guy right here is just a lens flare. It's from the overexposed moon, so that's a little lens ghost image right there. If I get to get the two moon dogs, I know these are real because I saw those naked eye as well before I took this image. So that's why I know they're not some optical phenomena from the camera lens, but this guy is definitely a little lens flare / ghost image. So moon dogs are much more rare just because the moon isn't as bright as the sun. So the sun is brighter, so it's more likely to form those. But near a full moon, you can sometimes get moon dogs. And I was happy to finally get them. I'd seen them before, but finally got the image about a year ago, I want to say.
Mhm.
Well, this is a fun one. I love doing this. This is one of my, what I always do with our education outreach activities. This is part of my day job. We do star parties out to Tohono O'odham Community College. Kit Peak is located on the O'odham land on a tribal reservation. And we work with a lot of education programs out there, and we do star parties out at Tohono O'odham Community College. And one thing that we did one year, we were talking about some activities doing, and one of the students suggested, why don't we launch water rockets? Because they'd seen us do that at another event, said we build water rockets out of 2-liter bottles and pressurize them and launch them. And they said, why don't we build water rockets? I said, yeah, but it's gonna be night. We won't be able to see them. And one of the students, this was one of their ideas. I can't remember, I think it was Calvert's idea was his name. I think Calvert said, why don't we take glow sticks to them? And I said, that's a neat idea. Yeah, let's do that. Let's tape some glow bracelets to the water rockets and launch them at night and see what happens. So of course I thought, of course, they're getting ready to launch the rockets. I thought, I bet this could make an interesting picture. So we had the Milky Way setting in the background there. This was there's an October star price, but the summer Milky Way setting in the west, in the southwest, and the water rocket going up. And I took about a 10-second exposure here with a very high ISO and a very fast lens, and got this. And it's a very interesting image. And I love these images because you can actually see they put different colored glow sticks on each side of the rocket. So you see there's where the green and yellow separate up here. That's because the green and yellow, the rocket's rotating as it flies, and you're seeing the green and yellow come in different angles to you. So you're seeing green and yellow as they spin around. Up here, it's obviously we see green on one side, yellow on the other, but here they sort of see only one as it rotates, and you only see one side of the rocket. So it's a really neat picture. I've taken lots of these pictures. They're a lot of fun. So if you want to do a really fun activity, buy a water rocket launcher from Arbor Scientific. They cost about $30. They're not too expensive. You know, Google water rockets. You find all kinds of great videos on how to build these things, attach fins and nose cones, you know, and then launch them at night with glow sticks attached and take a picture. They're just really, really fun pictures to take. They worked really well. They're just a lot of fun. So that's just one of my favorite little things. And this is actually one of those things that the school loves it too. The students love it. The teachers out there, the faculty out there love it. They use these in their publicities. They have these pictures up in their science department and use those in their science department brochures and everything, just some of the fun stuff they do. So they are a lot of fun to build these rockets and launch them and then get these pictures. So that was actually the last formal slide I had. I do have a few more solar pictures here if we want to just take a look at them. Actually, there's I can skip to this one here. Let's go to this one, skip that slide. But I did the transit of Venus, of course, back in 2005. Or 2012, excuse me, this 2012. 2005, I did not have a camera capable of doing the transit of Venus yet. DSLRs were still very expensive, and I was not shelling out that much money for DSLR at the time. But in 2012, this is my first DSLR, my old Canon XTI, Rebel XTI, not the big ones, but not my current cameras. But still good enough to do the transit of Venus and get the transit of Venus. Solar eclipse, I've done several solar eclipses there. I've done this I think the annular eclipse in 2012 in the Grand Canyon, if I remember correctly. Now the Ring of Fire, this is a fun one. I love this one. This is the Grand Canyon solar eclipse 2012, May 20th. And I loved it for several reasons. First, I was in the Grand Canyon and I had a great spot to watch it from. That was great. And then of course I got this picture on the right here, which is this partially eclipsed sun setting over the Grand Canyon. And much to my shock, the next day in the paper, I opened the newspaper and see a picture that looked almost exactly like mine. It wasn't mine, but it was very close. There was a guy standing next to me who was using this big white Canon L series lens, this big $10,000 lens, who was a Getty photographer. And you could tell that my picture and his were very, very close together. His was better, a little better because he had a better lens, but still, that's not bad. It's like, I did pretty good. I was close to what he was. I also think this was a special eclipse for me because if you're familiar with serocycles, eclipses repeat every 18 years, 10 days, and about 8 hours. I can't remember the exact number of hours, 8 hours and some minutes. And 94, 18 years before this, I was in grad school at Michigan State, just got my master's degree. Actually, I was a few days from getting my master's degree, just before graduation. It's been about May 10th. And so I saw that previous annual eclipse in this solar cycle in serocycle in Michigan. So sort of a nice, 18 years later, seeing eclipse in the same serocycle. And so if you want to really go down deep rabbit holes, look at serocycles of eclipses. And there's several eclipses. I've seen at least 2 eclipses from the same serocycle. So I got to tell you, okay, this eclipse I is here, this eclipse I is here. In fact, the 2017 solar eclipse was my second solar eclipse I'd seen. The first one was in 1999, which was in Germany. And I saw that again. Those are 2 18 years, same serocycle. So I've had several eclipses, both solar and lunar, I've seen same serocycle eclipses of. So here's I talk about solar eclipse maestro and lunar eclipse maestro. These are just some spare slides I had at the end. So this is my August 2017 eclipse, various exposure times. Again, this was all done with solar eclipse maestro without me touching cameras. So during the 2 minutes of totality, I took about 160 images, or the computer took about 160 images. no way I could do that by hand. No way anyone could do that by hand, taking that many images, changing the exposure and exposure time between each image. It just doesn't work. So automating the process like that, if you want to do these type of things, is the only way to go. And this is actually my first attempt at doing Eclipse composite, where I took a bunch of the images from very long exposures, some Earthshine, and some shorter exposure, short exposures to get the inner corona, longer exposure to get the outer corona and Earthshine as well, and layered them in Photoshop and combined them. So still, someone who really knows Photoshop could probably do a better job, but still, that's my first attempt at doing a very high definition composite in Photoshop. I think there were a dozen images combined in this one of different exposure times to try and get this. Of course, that's another moon halo. I actually think that might be the one I think is a different exposure time than the one I showed earlier. It's a longer exposure, which brings out the color of the tree a little bit better. I also do some wide field stuff, Mercury, Venus, Mars, Moon, Pleiades. I love some wide field stuff occasionally as well. So, and of course, I love doing things like Venus and crescent moon pictures, nice shots of those. Get some diffraction spikes on Venus if you use a little bit longer exposure. This is, yeah, I don't think there's 18 millimeters. The moon's way too big for that. I think that's information at the bottom is incorrect. Everything else might be, with 18 millimeters is definitely not correct. It's definitely a shorter, longer focal length than that. I'll do it. This is what fun looks. I got the Mars, Uranus, Venus, and crescent moon. So you get a little Uranus in there too. Sometimes you really look at, see what some ones are going around. See, I think I only have a couple more slides here. This did Venus, and where's Mercury in this one? So this is not one I was planning to show, but since we're still going, might as well go through the last. Oh yeah, Venus and Mercury right up here at the upper right is Mercury. So there's Mercury and Venus. Sometimes you get a nice little conjunction of those guys. What's this one? Moon, Venus, Mars, Mercury, and Pleiades. So you get all kinds of stuff and sometimes come together nicely. I also like that Venus has that 8-year cycle. So this 2020 last year, we had Venus and the Pleiades together. It was early this year. Yeah, early this year. I had pictures from 8 years ago and they're together as well. So that's also fun to get those pictures 8 years apart sometimes with Venus. This is actually from the Gort telescope up Sonoma State's Observatory. Venus, Mars, Saturn, Venus, Mars, and Saturn in 2010. So I believe that's Venus, then Mars and Saturn be these two guys up here. So it's up from reasonably close to where you are. Jeff Atkins was there that night, so that's where Jeff was at this night too, I believe. But yeah, so these are some more wider shots with the crescent moon down. Here's why I like this one. We have the Saturn, Venus, Mars, and moon up here, the Saturn, Venus, Mars, and the moon down the lower right. This is again Tucson from the west side where I shoot a lot of sunsets. This is a much wider field, obviously, than I do for sunsets. And a Venus and Pleiades from April 12 to 2012. I did it again in April 2020 last year when I did some more Venus shots. And I have Milky Way. This is one of my first shots for my 14 millimeter lenses. So a nice wide Milky Way shot. And a Kit Peak one. This part I call it my blue phase. I probably went a little aggressive on making the sky a little bit blue in this one. But I did get some nice air glow here, the greenish air glow. This is when that's ionized oxygen. During this day, the sun will ionize oxygen up atmosphere. If you're a very dark site, that ionized oxygen gives off this green glow sometimes. You can sometimes get it if you're in a very dark site. So I've gotten that a few times from Kit Peak. Not often, but a few times I've gotten that air glow. And another rocket launch. This one they did yellow and purple on the rocket instead. So the different colored glow sticks. I believe it has the same night, so the Milky Way looks about in the same place. Of course, I've done a few star trails too. This was the star trails over Kit Peak, about 300 images. I think there are 15-second exposures, 320 images or so. This is a nearly full moon night, so that's why the foreground is lit up so nicely with a nearly full moon night. And I like this shot a lot. This is the McMath Pierce Solar Telescope on Kit Peak. It looks sort of like a sideways 7. And of course, it's a polar aligned telescope. The entire building is polar aligned. So if you go down to the bottom of it and point at the top of the telescope, you see that the top of the telescope points straight at Polaris here. So you got Polaris literally at the top of this telescope, and everything rotates around the telescope. Again, there was a fairly bright moon this night. I think it was a waxing gibbous moon. So you got that nice illuminated telescope there. So, and this is Cerro Chololo Inter-American Observatory on a very, very dark night where I was able to get the star trails almost too bright over Cerro Chololo in Chile. That's the Blanco 4-meter telescope, which is where the dark energy survey was done. And the dark energy camera is still attached to that telescope. So they've been still using that. In fact, I'm sorry, I can't say that. There's a press release coming out about the dark energy survey this week, which is still embargoed. So I can't say anything about that. I almost broke embargo there. But look for a press release from dark energy survey later this week, I think Thursday, because that's probably on the news team someday. I have to remember what's embargoed and what's not. So, and I also done a couple of composites of meteors, and these are fun to do. I literally take a camera and just sit there and let it shoot shots all night long, shoot pictures for hours, just take 15, 20-second exposures, whatever it takes the time. And then of course you have to go through these hundreds of exposures, find all the pictures with the meteors in them, and then you go back and you not just you actually align them. So you rotate the entire field so the stars line up. Now you can sort of see the radiant of the things here. I think there were a couple I didn't quite align properly because I think I forgot to move the rotation point to Polaris for a couple of them. So I think this one might be a little bit off. This is my first attempt at doing a picture like this, but most of them look pretty good, but I think one or two of them might be off just a skosh. I didn't move that rotation point like I was supposed to. Or it could have just been a sporadic meteor too. And called a sporadic meteor did go in a different direction legitimately. Here's another Perseid composite as well from the same night, just different camera. I had 2 cameras going that night, which meant I had to go back and photograph go through literally 1,000 photos or so. So anyway, I think, and I got 1 aurora shot. I haven't done a lot of aurora photography living in Arizona, of course, but I was actually at Acadia National Park. This is in 2012, and we happened to get an auroral display. And there's a very old camera that didn't have nearly as sensitive as my newer ones, but still I was able to get an aurora shot with it, which made me happy just to get that aurora shot. And literally that 10mm fisheye lens right here that I talked about earlier, that 10mm f2.8 lens, I bought that lens literally a couple of weeks before this trip, thinking I'd get to use it in a dark site, and happened to get aurora on my first night out with it in that dark site. So that's very, very lucky and fortuitous timing. I got that night up there. I think that's that's pretty much my last slides. I go back into the satellite passes, iridium flares, which I already talked about a bit. I think that's, I think there's just repeat slides toward the end here. Oh, here's one more star trail slide to show, just because this is another star trail. Oops, I didn't want to start from the beginning. I want to start there. Here. Current slide, not first slide. This is sort of a fun one. There's actually a friend of mine I just set my camera out and let it go. And a friend of mine was actually out here still taking pictures, which her red light got a little close sometimes, did a little lens flare in my thing here. But I love that one. That's a very dark night as opposed to the moonlit nights. This is at the side of the road here. It was a very windy night, so I literally put the camera behind a shipping container, which contained which they delivered some equipment to Kit Peak. So I put behind the shipping container to shield it from the wind. And she was also huddled behind the shipping container with her red light. So you see some of her red light made a little contamination there, but hey, take what you get some nights. I do want to show one more picture, but it's not in the presentation. I think I'll stop sharing here and go to my Flickr account and find it, because it's a picture that I took from a lunar eclipse in Kit Peak a few years ago. I know you can't see my screen right now, but I'll share again once I find it.
Mhm.
Yeah, here's the actual right album. And this is sort of what we talked about earlier. Where's my Zoom? I get back to Zoom to share this screen. This was done with Lunar Eclipse Maestro, taking pictures. And again, this is taking a picture of, there were some clouds at night, so it's sort of an interesting picture here. You actually see part of a moon halo here as well, from one of the very bright images toward the end, the moon halo. But you actually see the pictures, just about 300 some pictures layered throughout the eclipse. Again, Lunar Eclipse Maestro did this at long exposure in the middle to get the foreground lit up. Totally eclipsed moon, then of course the moon coming out of eclipse on the other end, getting very overexposed. And you see a few of the brighter stars were picked up in all the pictures, and a few of the fainter stars picked up just in that long exposure in the middle. So you get all kinds of fun things going on in this image, which I thought was kind of just a fun image to create. Again, I'd love to play with this. There's a lot of ways to process this image. I'm sure I could find other creative things to do with this image as well. But the fun thing about this night was, that's nice. That's trans that night with the fisheye lens. Trying to get to other pictures from this night. Maybe that's the last picture of this night. May have to go that direction. Yeah, here's actually a time lapse of this whole eclipse. Just a single picture camera taken time lapse of the eclipse. And then it comes back on there at the end. Can't remember what my exposure said. I think that was aperture exposure that I put on, just aperture exposure and just let it run. We actually see that moon halo was there throughout much of the night too, which was fun. It was a partly cloudy night, a lot of passing clouds, but never enough to totally block the moon. And if we had that sort of weather tomorrow morning, I'd be happy because, like I said, forecast not look good at this point. But I'm still up here and still hoping to get it. So with that, I will call it and open up to questions, discussion.
Okay.
Oh, I see. What do I want to capture? I see an interesting question there. What do I want to capture that I haven't yet? Oh God. I would love to catch Halley's Comet when it comes back again. I'll be in my 90s at the time, but I'd love to catch that. I also am looking forward to August 12th, 2045. That is a solar eclipse. That's a 6-minute long solar eclipse. And you get 6 minutes of totality at, everyone brace yourselves and make sure you're really properly braced. 6 minutes of totality at Disney World. I'm not making that up. I want to be at Disney World on August 12th, 2045 to capture that solar eclipse. So that is people who know me, I have a Disney running shirt on here now. I'm a big Disney person, so I've run the Disney Marathon every year since 1997, including the virtual one this year because it wasn't in person, but I go Disney all the time and love to be there for that solar eclipse in 2045. I think those are a couple things that are definitely come to mind. Any great comet, I'd love to get another great comet. A daytime comet would be spectacular. I've never gotten a daytime comet. That'd be a wonderful one to get. So those are some fun ones. Those are three that come readily to mind. I'd love to get that in the future.
Yeah, anybody would like to get a great comet.
Well,
Well,
my cat was named
that's
Hail
one
Bob.
right there. That's one right there. So
Well, Comet Neowise was pretty darn good. I thought Comet Neowise was really good. I thought it was an underrated comet. And do I have that picture of, oh God, I wish I had that. I can't remember if I actually posted that picture or not. I might have to look at my Facebook page. Oh, here it is. Yes, I did post it. This was I'll share this screen too. I did post it, so I do have access to it. This, remember 2013 Comet Pan-STARRS. A lot of people were very disappointed with it because they thought, oh, it was never really visible in a dark sky. It was only visible right after sunset. But this is actually Comet Pan-STARRS. And this is an interesting picture. It was by the crescent moon. I wanted to get by the crescent moon that night. This was a challenging picture. And of course, it was still in bright twilight. You see the comet up here with a little bit of a tail. This was a challenging picture because I was actually traveling at the time. And I was literally on a layover. I was on a layover at Dallas Airport, Dallas-Fort Worth Airport. And I was trying to figure out how I could get a picture of it during my layover. And the Grand Hyatt Hotel at DFW in Terminal D has a rooftop pool. And my flight went out of Terminal D. So literally on my layover, I went outside security, went to the Grand Hyatt, asked them if I go to the roof because you had to have a key to operate the elevator. The very nice person at the desk activate the elevator. So I go to the roof of the pool and take this picture during my layover. And they say it's not very visible, but I saw it easy naked eye from Dallas-Fort Worth Airport, for crying out loud. That's not a dark sight. That's not a dark sight. It was an easy naked eye object. And so there were obviously clouds rolling through, which I think made it kind of a dramatic photo, to be honest. But I kind of like that photo too. That's kind of a fun one to get, which is kind of shows the sort of links I go to grab a photo sometime. I'd leave security in the airport and go outside and just try and grab a picture during a layover to the airport. Yep, Mount Diablo during a public night. You talk about the Comet Pan-STARRS, the 2013 one. Someone said they saw it from Mount Diablo during a public night. Yeah. That's when you talk about, yeah. That was a fun one to get. That was definitely a fun one. I didn't put them all in here because I don't have time to go through everything, but I've gotten a couple of fun ones. There's a comet a couple of years ago past the Owl Nebula that I got with my DSLR and a zoom lens. So I don't know if that one's easily accessible or not. I can look for that one, see if I get that one. Because the Owl Nebula will probably, yep, Comet 46. That's right. That's one came by the, and again, this was with my camera and zoom lens. I can share this screen. This is Comet 46P Tuttle. Let's see, is this the right one to share? Yes, I believe that is. But you get the comet here. You get the M108, I believe that is, and the Owl Nebula right there. That's with the 600mm zoom lens, the sky tracker. I forget what this star is. I think this is one of the stars in the Big Dipper, but I forget which one in the upper left. See a nice bright star in there too. So it's not that, you know, for relatively modest equipment, you get stuff like that. And of course, there are some people who got spectacular images using much larger equipment. So it's a fun little thing to try to do what you can get with those type things. Those unusual alignments, like I said, those are the fun ones to get.
Okay. Well, for some reason or other, my chat has frozen. I don't know why. I don't see anything later than.
I don't see any other questions there either. So
Yeah.
it's usually getting close to your end time, right?
Oh yeah. Well, yeah. I think we're wrapping up here.
Okay.
So, wow, that was an awful lot of pictures there, Rob.
Yeah. Well, I will tell you, if you search for me, I'm on Flickr, and Flickr is probably the best place. And I'm also on Twitter. Oops, I actually said direct message. Didn't mean to send that to. I wouldn't send that to everyone, not just you. But my sort of my brand, my nickname on online is Half Astro. So if you search for Half Astro, you'll find my Flickr and my Twitter and Instagram, that sort of thing. So it's short for Half Astrophysicist, which shows you the level of maturity of my humor as well.
Right. Exactly. All right.
But it's memorable, so that's the important thing.
I don't know if anybody had any questions. There's now a couple of chats came up. There you go. Oh, that was you. Okay.
Yeah, that was my putting Half Astro, and I see someone saying, see a lot of thank yous. You're welcome. It's always a pleasure to be able to share some of this stuff and share some of the fun things I've done over the years with people who appreciate it and know that's how challenging some of this stuff can be.
Yeah. Well, I was in the middle of mentioning that, yeah, there's lots of pictures, but you took a lot of pictures to get the ones that you have. So
Yes. Oh yeah, oh boy, yeah. That you don't want to see some of the ones I haven't shown, that's for sure.
oh yeah. Well, when I was taking pictures of Perseids and Leonids and Geminids with film cameras, there is a bunch of rolls of film I ain't got nothing on them.
And that's the wonderful thing about now we do digital. It's like it's all photons and it's a battery recharge, right? That's a battery recharge and some hard disk space, which is cheap these days.
Exactly. Yep. Okay. Well, I think if there's no other questions, I think we're done for the night. And everybody's got to get up early in the morning to watch a lunar eclipse, right?
Yep, but I have to go out and scout my location right now, so I can figure out exactly where I'm going to set up.
Okay. Well, I think with that, I think we're done tonight. So thank you very much again, Rob. And
You're welcome.
Thank you everybody for showing up. And again, we'll have our next general meeting June 22nd.
Okay.
Good night.
Good night.
Rob,
Yes?
come back, please.
Okay. Yeah, I'd be happy to come back again sometime.
You're very easy on the ears.
Well, thank you. Have a good night.
You too.